Hello and welcome to Sources classes. In this lesson we will learn about matrices. Now what is a matrix? A matrix is basically a set of mn numbers, which means m into n numbers arranged in the form of rectangular array of m rows and n columns is called a matrix. For example, A is a matrix of the order m cross n. A11, A21, A13 till A1n, and this will go till AM1, AM2 till AMN. This is a basic matrix. Now we'll learn about some important terminologies in matrix. First of all, row matrix. What are row matrix? A matrix having only one row is called a row matrix or a row vector. For example, A, B, C, D, E. This is a row matrix. Similarly, what are column matrix? A column matrix having only one column is called a column matrix or a column vector. A, B, C, D. Now we move on to a square matrix. In the above mentioned matrix, in the determinant, it was of the order m cross n. Now, if m is equal to n, then the matrix is said to be a square matrix. For example, if I give a 3 cross 3 square matrix, m is equal to 3 is equal to n, which means 3 rows and 3 columns, I'll write A, B, C, D, E, F, G, H, I. 3 rows and 3 columns. This is a square matrix. Next we come to diagonal matrix. Now what are diagonal matrix? A square matrix such as A is equal to Aij, order is n cross n. It is called a diagonal matrix if all the elements except those in the leading diagonal are 0. Now students, let me tell you what is a leading diagonal. The diagonal from left to right, that is this diagonal, is known as the leading diagonal. A, E and I. So I repeat, a square matrix is called a diagonal matrix if all the elements except those in the leading diagonal are 0. For example, if I write a matrix 1, 0, 0, 0, 0, 3, 0, 0, 0, 0, 4, 0, 0, 0, 6, 0, 0, 0 and 6. Clearly the principal diagonal or the leading diagonal is from left to right, and this is 1, 3, 4 and 6, except this all the elements are nil or 0. Hence this is a diagonal matrix. Now what are identity or unit matrix? A unit matrix or identity matrix is basically a diagonal matrix with all the diagonal elements equal to 1. For example, if I write 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a 3 cross 3 unit matrix. It is also represented as I3. 3 because the order of the matrix is 3 cross 3. This is a squared matrix. Now we'll learn about null matrices. Now what are null matrices? Matrices whose all the elements are 0 are called null matrices or a zero matrix. For example, if A is a matrix with all the elements 0, this is called a null matrix. Now we move on to upper triangular matrix. A square matrix is called the upper triangular matrix, where all the elements before the main diagonal or the principal diagonal are 0. For example, if I write, if K is a matrix having elements 1, 2, 3, 0, 0, 5, 0, 0, 6, then all the elements below the principal diagonal, that is this, if these are 0, then this matrix is known as upper triangular matrix. Similarly, for lower triangular matrix, the elements above the principal diagonal must be equal to 0. For example, 1, 0, 0, 1, 1, 0, 1, 1, 0. Then this is the principal diagonal, all the elements above it are equal to 0, hence it is a lower triangular matrix. Now we'll learn about some operations on matrix. For example, addition. A, B, C, D, E, F, G, H, I be one matrix. Let us name it as A, and another matrix A dash be K, L, J, K, L, M, N, O, P, Q, R. Now if we add these two matrices, we'll get A plus J, B plus K, C plus L, D plus M, E plus N, F plus O, G plus P, H plus Q, I plus R. Each of the corresponding elements are added together. This is same for subtraction, only this positive sign is replaced by a negative sign. Now we'll learn about some basic properties of matrix of addition. Matrix addition is commutative. That is, A plus B is equal to B plus A. Second property is that it is associative. If A, B and C are three matrices of the same order, then A plus B into plus C is equal to A plus B plus C. Third property says that the null matrix or the zero matrix is identity element for matrix addition. For example, A plus 0 is equal to 0 plus A, which is equal to A. Here this 0 does not represent 0, the point on the number line, but it is a symbol for null matrix. 0, or rather O we say. Now the cancellation laws. It says that if A, B and C are matrices of same order, then if A plus B is equal to A plus C, this implies B is equal to C by left cancellation. Similarly, if B plus A is equal to C plus A, which implies B is equal to C by right cancellation law. Now, what about scalar multiplication? Let K belong to a real number, which is scalar quantity, and if we multiply it to A plus B, then we get K into A plus B. This is equal to K times A plus k times b. Here the scalar k is multiplied to a, which means it is multiplied with each and every element of a. Now, how to multiply to matrix? For this, I'll take two simple matrices and multiply them. This will be easy for understanding. A is equal to and B is equal to. Let us take this matrix as 1 0 1 2 3 6 1 0 0, and this matrix be 0 0 1 1 0 0 0 0 10. Now if we need to multiply A into B, that is 1 0 1 2 3 6 1 0 0 into 0 0 1 1 0 0 0 0 10. What we need to do is, for the first element of the new matrix, take the first row of the first matrix and the first column of the first matrix and multiply the corresponding elements, that is 1 into 0, and add them, multiply and add them. 1 into 0 plus 0 into 1 plus 1 into 0. 1 into 0 plus 0 into 1 plus 1 into 0. Similarly, for the second element, keep the first row of the first matrix, that is the left matrix, constant, and change the column to the second column of the second matrix. We'll get 1 into 0 plus 0 into 0 plus 1 into 0, that comes to be 0. Similarly, change it to the third column, we'll get 1 into 1 plus 0 into 0 plus 1 into 10, that comes out to be 11. Now change the first row to the second row and repeat with all these three columns. Hence we get the next values as 3 0 62 0 0 1. Now there is one more trick to guess the order of the final matrix, that is, this initial matrix is 3 cross 3 and the second matrix is also 3 cross 3. Hence take the value of the row of the first matrix and the value of the column of the second matrix, that is 3 cross 3 again, hence the order is 3 cross 3. For example, if we multiply A, which is of the order of 2 cross 3, and B may the order 3 cross 2, then we take 2 from the left and this 2 from the right, and we will get a new matrix K, which is the product of A and B of the order 2 cross 2. Hope you understood this. Now we'll learn about properties of multiplication. Matrix multiplication is not commutative in general, that is, A into B is not equal to B into A. But matrix multiplication is associative, that is, AB into C is equal to A into BC. The property number 3 says that matrix multiplication is distributive over matrix addition, that is, A into B plus C is equal to AB plus AC, and A plus B into C is equal to AC plus BC. Then the next property says that if I be the identity matrix, then I into any matrix gives us that matrix itself. Fifth property says that the product of two matrices can be the null matrix while neither of them is a null matrix, that is, A into B may be equal to 0 when A not equal to 0 and B not equal to 0. Here 0 means the null matrix. It is possible. Now some basic terminologies. Now idempotent matrix. Idempotent matrix. A square matrix A is called idempotent matrix if A square gives us A. Remember, where A is a square matrix. Now what are nilpotent matrix? A square matrix A is said to be a nilpotent matrix of order n if n is the smallest positive integer such that a to the power n is equal to null matrix. Let A be a matrix of order m cross m. Therefore, the smallest value of n for which a to the power n is equal to the null matrix is known as, then A will be called as a nilpotent matrix of the order n. Now transpose of a matrix. If A be a matrix of m cross n order with elements a, I, j, where I is equal to 0 to and j is equal to 0 to n, then transpose of A is represented by a to the power t. This is equal to matrix with elements with a reverse order, that is AJI. Let me give you an example, then it will be more clear. For example, if I write the matrix A, B, C, D, E, F, G, H, I, J, K and L. Let this be A. Therefore, the transpose of A will be A, E, I, that is, we are reversing the element. These elements are going there and these elements are coming down. Next will be, the elements will be B, F, J, C, G, K and D, H, L. Let me do one more example, then it will be more clear to you. Let us take numbers this time. 2, 3, 5, 6, 7, 8, 21, 0, 0. Now what is the transpose of this? The transpose of this will be simply 2, 3, 5, 6, 7, 8, 21, 0, 0. Basically, what we are writing in the rows in the first matrix, change it to columns. We should write the same row as in columns. 2, 3, 5 row in the first matrix A, then A dash will be 2, 3, 5 the row.